We're given question 2.1 says simplify the following without using a calculator. Okay guys, this is NCV level 4, right? So we're dealing with trigonometric path. Okay. 2.2.1, we're given 1 minus 2 sine squared 15, right, degrees there. That is what we have. So to simplify, as you can see, this is a double angle, guys. This is simply equals to what? This is a double angle, right? Will be simply equals to sine. Then here we'll have 2 times 15, right? Then you know this will be sine 30 degrees. This is what we have there. Okay, now 2.2, still under simplification. We have sine 96 degree multiplied by cos 24 minus sine 24 degrees multiplied by cos 276 degree, right? This is what we have when the angle, always use the reduction formula. If the angle is greater than 90, if your angle is greater than 90, use a reduction formula to reduce the angle. You can apply your cast diagram. You have sine 96, and then if you are given a cast diagram, this is 96 is somewhere on the second quadrant, and then on the second quadrant we know it's what, it's 180 minus theta. So we'll use this, we'll reduct that. So simply have sine 180, for us to have that 180 minus 96 will be 84. Oh good, we'll have 84. This will be minus 84 degrees, right? This is what we have. This will bring, if we subtract that, we'll get 96. So we're still on the right track. Multiply by, this is less than 9 to leave it as it is, cos 24 degrees. There we have minus sine 24 degrees. This is less than 90. Don't reduce that. This is greater than 90 degrees, so we reduce that. So if you have a cast diagram, it's 90, 180, 270, but you see it's 276. That means it lies here on what, on the third quadrant, which is 360 minus theta. And then we know that all students take calculus, right? That is why. So here we'll have this, is what we'll have there. It will be multiplied by what, cos, we'll have 360, we'll minus that 360 minus that 76, 276. So this also will be 84 degrees, guys. Also that will be 84 degrees. So yeah, then here we'll have, this will be simply equals to sine 84. Obvious is positive there, sine multiplied by cos 24 minus sine 24 multiplied by cos 84 degrees. So as you can see, guys, 84, 24, 24. This is a compound of what, of sine. So this will simply equals to sine 84 degrees minus 24 degrees. Then this sine, okay, supposed to put some equal sign there. Then you say 84 minus 24. This is equals to 60 degrees, which is, this is a special angle. Then we know sine 60, it's a special angle, which is equal to square root of 3 over 2. This is what we have here, guys. This will simplify to that. Okay, so question 2.3 have given here, we're given cos 75 degrees. So okay, we want to do this cos 75 degrees. Cos 75 degrees, we can rewrite this is the same as cos. Use special angles, apply your special angles, guys. Use special angles. You know special angles, we have 90, 30, 45, we have what, 60. These are special angles, right? As you can see, 30 plus this is what? Is 75. So yeah, so can use 45 plus 30, can rewrite that, applying our special angles, right? So we have rewrite this will bring us back here. Remember, when you add, we did not change anything. So but this is a compound angle, but compound angle of what? Of cos, will have cos 45 degrees multiplied by cos 30. We change that sign there to become minus. We'll have sine 45 degrees multiplied by sine 30. Then we know, then we'll apply our special angles, guys. That is 45. You see, we're left with special angles. This is the same as 1 over square root 2. From where did I get that? From this triangle 90, we have 45 degrees. If you have this here, we have 1, you have square root of 2. Is it, guys? Is what we have, what we know actually. So this is what we have, guys, there. Then we have, this is our special angles, you can apply that. Then you also have cos 30. This will be multiplied by, so let me just apply the brackets like this for it. That will be square root of 2 of 3. Okay, square root of 3 over 2 minus sine 45, which is opposite, over that thing. Apply, use your special angle. This is same as opposite. This will be the same as 1 over square root 2, right? Multiply by sine 30. We know that sine 30 will be simply equals to 1 over 2. Then there we go, guys. We don't use a calculator, it's a multiplication. You multiply the top and the top, the bottom and the bottom. Then we'll have square root of 3 over square root of 2. Okay, no, right? Yes, we have this. When multiply, this will be 2 here and square root of 2, right? Then we subtract, you have this minus here, we multiply, they will have 1. Then when you multiply this, we'll have 2 square root of 2. This is what we have. So as you can see, our denominator is the same. Now on the right track, we simply equals to 3 minus 1 over 2 root. You see is what we have. So I don't like to have a only your denominator, do not leave it sets. I don't like to have a square root So I will simply multiply by the square root of 2, everything there. If I multiply, this will goes there and goes there, so we'll have square root of what? Of 6 minus square root of 2 all over 4. Right, this is what we have there. Maybe you may be wondered, why do I say square root of 6? You apply this rule. Remember, if you have a multiply square root of a multiplied by the square root of b, because these things, all of them, they are both under the square, you take the big square, then you multiply what is inside the square root. So I use that law there. We have 3 multiplied by square root of 2, both under the square root. I will simply take the big square root, then I multiply what is inside. This is simply what? 6, right? Yes. So yeah, this is what we have, guys. 2.2, calculate the values of x, given that we are given that sine 2x plus sine x is equal to 6 cos x, right? Cos x plus 3. This is what we have. Sine 2x plus sine x 6 cos. All right, this is what we have, buddy. Now I have this, as you can see. So this is a general solution. We want to calculate, so but calculate the values. Okay, there's of x, you see the one values there. Oh, okay, not a values. Okay, it's fine. Okay, guys, we have this now. Okay, just say sine 2x plus sine x. Take that to the other side. I'll have minus 6 cos x plus 3 is equals to 0 is what we have. So okay, we have how many things here? 1 2 3 4. You see, when we have 4 terms, we have 4 terms here. You must vectorize by grouping. When you're given 4 terms, vectorize by grouping. Factorize by grouping. If you are given 4 terms, factorize by grouping. So we factorize by grouping here. So we start by these 2, right? What is common between these 2? Okay, before that, let's just change this first. We'll have 2 sine x multiplied by cos x plus sine x minus 6 cos x plus 3 is equal to 0. Then factorize by grouping. What is common here between these two? What is common there? Let's check. We have its sine. We'll take out sine x as a common factor. We'll be left with 2. These 2 here will be left, and we're left with this cos will be 2, right there. When you take out this, we're left with what? With 1. We'll have plus 1. So yeah, now let's go here. We have 3. I know that will be 3, the common factor. I will have now, let's check, we have must be the same. These brackets must make sure the second bracket is become the same as the first one. How can we do that? If I take out the -3 for in case, there I will have what? If I take, I'll have +2 cos x, then here I will have -1 is equal to 0. So you see this is not the same. So if the brackets are not the same, as you can see, these things are not the same. If you multiply that, okay, you'll bring you back there, but as you can see, these things are not the same. Minus, and this is not the same thing. So what can you do there? What can you do there? All right, so let's take out, we can take out the negative here. If I want this to become, I can take out, okay, fine, that is 6 is what? This is negative, right? Let me check here, I'm correct. Yeah, will be negative when I also this. Think here I made a mistake, guys. As you can see, okay, I wondered, this is positive, this is supposed to be negative. Sorry about this silly mistake. Remember, when I take this to the other side, must be negative also, because when I transpose this to the side, must be negative. Okay, guys, so sorry about this. Will be also here, I will have -3. So yeah, now we can factor out the negative. Right here we'll have plus. Simple. When you take out the -3 here, when you substitute, when you multiply this here, will bring us back there. When I substitute here, I will get back there with those negatives. So yeah, so this and this is the same. So we take one of these brackets inside the same, can take like that, and take this, and take that and put it here on this bracket, sine x, and take this including the sine, then this is equal to 0. Then here we'll have 2 cos x plus 1 must be equal to 0, or sine x minus 3 must be equals to 0. Then cos x will be equal to, you take that, will be minus, you divide by 2, we'll have this. Then here we'll have sine simply equals to 3. Okay, we have two general solutions here. You can say x, I will decide not to put the negative, I'll just put this positive also here. I will have, then I put 3 there. So this is negative, cos is negative where you come and check here, cos is negative here, check the quadrants, is negative where, you know, here all student take calculus, cos is negative where, third quadrant and the second quadrant, then there is negative. So say shift cos, put that 1/2 on your calculator, you'll have 60. Then we have here 60, this is just a ref angle. There, this side our sign is positive. Okay, also we say sine, put 3 there. This is 3, that is 3. Oh, would be 3 either way. Then 3 must it's undefined either way. The 3 is undefined, this one is undefined. There's no way. There's no way. 3 is undefined. This one it's undefined. Remember, because the maximum value is between, the range of sign is between -1 and 1. So this is not applicable. So we have x equal to 60. We check this is negative on the second quadrant. Second quadrant, we know on the second quadrant we have 180 minus theta, so we have 180 minus 60. There will have 120 degrees, so that is x there. For checking here, because they want the values, for me to check here, they want the values between that. For the values, for argument's sake, I can say this, can say plus 360 k, it's an element of integers, k it's an element k it's an element of integers. So I want to say, okay, k is an element of integers. Fine, let me, this is a second quadrant, so I also on the third quadrant will have x is equal to 180 plus that angle, which is 60 degrees. When I add, I'll have 240 degrees. Then I can say, for argument's sake, okay, can say 240 degrees plus 360 k is element of integers. I want to find the values there, the values of x here. Remember, they want the values from our question, the values of x, where x is element from 360 to 360. I want to replace here, replace 1, where you see k, replace that with 1. We'll have 240 plus 360, then I put 1 there, 600, which is out, it cannot be there. I put -1, which is negative, which is won't be there. If I put in, won't be there. I put 2, won't be there. I can put 1/2, nothing there. Say 3, not there. Okay, let me check from the first quadrant. That one does not work. Let me try and replace 1 there. 120 plus 360. Replace that with 1. 480, which is not there. I replace again with 1/2. It's 300. So we have 300 here. I just replaced there with 1/2. Let me say 3/, okay, let me say 4. It grows 4/1, 1/4. Can replace this with 1/4. Let me check. I will get 210 range. 1/5. Get 192. Replace that with 1/6. It will be 180 until there. Yeah, you see, we have this there. 1 marks in a way. But the important step is this, guys. Is this one. You can The important step is this one, right there. You see, this is important step there. We are fine there. Let's go to 2.3.1. We have there, we're just given simply 1 plus sine 2x all over sine squared x must be equals to 1 plus cos x over sine x square. Should prove, okay, it's trigonometric identity, must prove this. Call these proofs trigonometric identities. Let's prove this. I will take maybe the left hand side for argument's sake. You can also choose the right hand side if you want. You can do the both. You can do both if you want. Okay, we can do both. Let me start with the left hand side. Let me choose the left hand side. There I have 1. I will choose this side. 1 sine 2x over sine squared x. Decided to choose that. When I simplify this, 1, I check. Okay, I have 1 there. But here, okay, it's fine. Let me just a bit, I don't want this one. Let me just simplify that a bit. This one is the same as sine x plus cos x all over sine x raised to the power of 2. Okay, I'm comfortable if it's like this. I want to come here. And then it will be simple like that. Okay, fine. Then I know here I don't have 1. I have sine plus cos here on top. The aim is to eliminate that 1. If I eliminate that 1, I don't have 1 is equivalent to what I want to eliminate, because here I don't have 1. As you can see, we don't have 1 here on our numerator. So it's possible. Let me eliminate that 1. Will be sine squared x plus cos squared x. Let me change this. This is the same as plus to this double angle sine x multiplied by cos x all over sine squared x. Let's check here. We have sine. Okay, we're on the right track. Let us not change this one. Then this is the same as sine x plus 2. Okay, we have squared plus 2 sine x multiplied by cos x plus cos squared x all over sine squared x. But that on the top, as you can see, this on the numerator, we know this is that on the form. You know most that form. That is the form that you remember. This form, we have that there, that format, which there will be sine x plus cos x squared all over sine squared x. This is what we have. So actually, what do we have here? What do we want to prove is that okay, we want to come here. As you can see, we have plus. Okay, it's fine. Oh, this is good. Now here we have sine. There is no squared. Also here there is no squared. Squared is outside. We need to be wise here. You see, we have squared. Okay, already we have that. As you can see, this is the same thing and this is the same thing, but here we have squared. Oh, since we have squared, that is fine. What can we do? Since we have squared also here, you see, also we have squared, I can rewrite this as I have sine x plus cos x, or plus cos x, yeah, what? Then over sine x. You see, because we have this already, this is 2 squared, also this. Okay, or let me take step by step so that you'll understand. I'll use which rule. Okay, let me leave this. Let me just write this as cos x. Then we have that squared, isn't it? Also, let me say step by step so that you'll understand. This is the same as squared. So using this rule, algebra, this will be same as a squared over b squared. So what we have, what is inside must come there definitely. So either way, now we see we have this, we have that, so we can put them on a, as you can see, on the same bracket. Is what we have. Most can put that on the same bracket, which is simply this, which is simply equals to sine x plus cos x all over sine x. Then we just, so this is the one and the same thing, but if you want it to be exactly like that, you can divide this and also divide that. Use this rule, a plus b over c is equal, is the same as a, you take that, it will be a over c, also take that plus b over c. You can use that, here will be sine x if you want over c over sine x plus cos x over sine x, but we have this all over squared, right? Then we know this will be 1, so we'll have 1 plus cos x sine x. So yeah, the left hand side is equals to the right hand side, as you can see here. There, you're right. We're done proving this. Left hand side is equal to the right hand side. Let us prove another one. 2.3. We have that 2 sine x multiplied by cos. Oh, let me take this here a bit. Oh, yes, we have this all over cos to the power 4x minus sine to the power 4x will be equals to tan 2x. This is what we're supposed to have. We prove this. I will choose the left hand side, which is 2 sine x multiplied by cos x all over power 4x minus sine power 4x. Right, I have a flu here, guys. Forgive me. Okay, fine. Let's continue. Yeah, I can say equal. We want to prove that we want to come here, isn't it? So let's prove then. Simply, you can simply see this is a double angle of sine, isn't it? Will be sine 2x all over. The aim The aim is to sine. We must check tan is the same as sine 2x over cos 2x. The aim here on the top, here on the numerator, we're supposed to have what? Sine. We don't want to have that cos there. We must eliminate this cos as far as possible. On the denominator we have cos. We must eliminate this sine. We just can see how, but all we know, the aim is to have sine on the top, on the bottom to have cos, right? So we must eliminate that. Work on eliminating that, but using maths, not dropping. Using maths. So we change this to be that. We are fine now. We have sine. So here we have sine. So there's nothing we can do. At least now we have this. Only here we're on the right track. We're right. So what is left is this one now. We must eliminate this thing here. We must have that. We must eliminate this. I don't want this. We must eliminate because here I have cos. So it's fine. Let us drop the stories. It's enough with the stories anyway. Let us kill our thing here. Okay. If I can see this, I can rewrite this. Difference of 4 squares my rule be cos we have cos 2x minus sine squared, because that is a difference of what? Of squares. As you can see, this is a difference of squares of 4. How this is the same as like this. So we are applying a math. We want to eliminate this. Is already we have eliminated that. That would be, oh sorry, ish, sorry about that. Hey, I almost fall. Okay, enough it's just so on top. We're on the right track. Now this is 1, same as 1. When we multiply by 1, remember this will give us 1. When we multiply this by 1, we're simply gonna get squared x minus sine squared x, either way. Right, so I want to have, the aim is to have now this, have to have this. So this, as you can see, this is a what? Double angle of cos. Now we are good to go. Sine 2x all over cos 2x. So guys, guess what, ladies and gents? This is simply equals to tan. This simply equals to tan 2x. Therefore, left hand side is equals to the right hand side. We're good to go. Yeah, these are just steps that you need to take, guys. So do we have anything here? We are done. We are done. Okay, guys, thank you, Lord. Thank you, guys. Thank you a lot for your time. Please don't forget to subscribe to my YouTube channel, guys. So also, guys, you can comment, right? Like, also feel free to like and comment. You can feel free also to share this to your fellow classmates. Thank you, guys. When you subscribe, help me, guys, to bring more questioning, to bring more solutions to you guys. Thank you for your time.